Hi everyone, myself Bhagyashree and today I'm going to solve one of the PhD problem which is majorly asking Microsoft, Paytm and Amazon company. It is a medium category. You can see the question is about construct a binary tree from the pre-order and in-order tree. So if you know about the pre-order in-order, that will be good because without that knowledge, this problem is not you get understand. So and the pre-order, what we can see, what is the difference between the pre-order and in-order? We can see what is the root value we are getting in the first index that will be coming as the second index in the in-order, because as the name suggests, pre-order means it will be first root value coming first. In-order means the root value coming in the, like we have a left, right and root node value. So the root value will be coming after the left, so first one and second position will be our, I can say, root value. So what we are getting in the first root value, in the in order we are getting the second number, I can say. As you can see, this is the input they are given 3, 9, 20, 57. Yeah, so in this input you can see that 3 will be a root node, but in the in order it will be coming in a second position, because pre-order, like we have the root value left and right, but in the in order we have a left, root and right value. So basis on these two input, we have to create the one of the binary tree, I can say. So let's start with this. I can say you got the idea about this pre-order and in order, and basis on that, because it is a very mandatory, you have to know what is the order traversal, or what is the pre-order, in order, post order. So yeah, I will start from this. And first of all, I have to try this pre-order. Basis on that, I have to find on the index in the in order. Like if I get the 3 number from this pre-order, I have to check this 3 will be coming at which position. As now normally we know, like it will be coming in the second position, but in the code wise I have to keep the track of that. So that's why I have to create the one of the variable which will be keep track of this. So I will create the one variable that in pre-order index, I can say. So it will be easy for us to keep the track of this. Private int pre-order index. Initially I have to keep the 0. Okay, and you can see this will be not solved as a like single approach, I can say. I have to apply this logic to check from this pre-order in order to create the binary tree recursively. So in this code you can see we have to apply the some recursive approach here. So first condition I created, then what I can say next, I have to do first start condition, call this return build tree with the help of recursive call. So I will return here pre-order, in order, and from start to end. So this will be starting point, and what will be our ending point? Ending point should be always our in order dot length. So I have to create the build tree, and for this you can see we have a pre-order, in order. So what I can use, I just mentioned I use the pre-order index for keeping the track of this value, what we are getting from the pre-order value, which we will be find in the in order. So for that reason I am using this variable, and coming to the recursive call, why we are using, because if it has become a very large input, then it will be difficult. So what we can do, we can recursively call with this help of this pre-order value, in order value, to create the build tree or binary tree, I can say. Then that's why I just created the recursive call for this one. And in the recursive call, we know we have to do base conditions. So this all the base condition we are applying in this function. Again, I will create one of the function for this one. So yeah, we have a pre-order, in order, and start to end value. Okay, so after this I have to create this main logic here in the recursive call build tree. In the private tree, what I can do, the private. Similarly, I have to create this build tree. So similarly, by private tree node build tree, from index I have to use the pre-order, in order, then in start and in end. So similarly I have to be in order, in uh, sorry, pre-order. As the sequence we are mentioning here, I have to follow that. So pre-order, in order, and I have to be with the start and end position. end position. Okay, this will be just little bit. Yeah, so after this I have to write the base condition. What will be our base condition? First I have to check the base condition for this. If our starting point will be greater than ending point, then it will be no use to create the build tree. Obviously, when we have any, like, I have to create the node, or I have to create the binary tree. So if starting point will be a greater than end point, so it will be no use, not possible to, I can say. I will check start is greater than end, then return null. It will be one of the base condition. Then second, what we can check, I have to create the node value. Like I can say I have this input, so I have to first create this node value, then after that create the left and right. So I have to take this root value. For that I just create one variable which will be taking our root value. Root value I'm taking, like we have a first pre-order, so I will take the root value from this pre-order and check that root value coming in the in order which position. As the pre-order we had, and I created the one index, so I will keep that index here also. Just minimizing. It will be our index. Okay, so you can see I put it the value, or keeping the value from this pre-order, and every time when I'm creating the node value or root value, I will taking from this index value and implementing. Okay, and after this I have to find the index of the node in the in order. So I just index from array dot index of in order root dot value. Okay, so for creating any tree, binary tree, I have to first root value, then left, then right. So our root value we are fine, and oh my god, it will be its index. Yeah. After that, I have to find the left and right. And left equal to not left. Sorry, root left. Root dot left I have to be fine. Similarly for the root dot right also. So this root dot left I will recursively call this build tree function, and I will pass this pre-order in order start and index. Pre-order in order from start to end. Index minus 1. Similarly for the right one also. From start to this index minus 1. Similarly for this right side I have to do no. Similarly for this right hand side I have to go like, I will type this index minus 1 to end. I have to be reach. As you can see, we have 0 to, like I have some like 0 to 6 numbers, so 0 to 3, then 3 to 6. So similarly here also start to index minus 1, then index plus 1 to n. So basis on that we are getting the left and right value. I think you got the idea how we are calculating the root left and root right. You can see this one will be our minus side, this one will be our plus side. In the number line you can see we have a left and right side, left will be a minus and right will be a plus. So basis on that logic we are getting the root left and root right value. So we got the root value, root left, root right. So for the creation of the binary tree, this all the parameter is needed, then we are getting from this, and final will be our root is ready. I have to return the root. Just check. Now code is completed. I will run this condition. Why this index of not containing? We are getting the index of uh, function name. I write the wrong. Okay. So now you can see my code is accepted here and test case is also passed. Let's submit the code. Yeah, our code is submitted also. You can see runtime and memory time what we are using. Okay, so that's it for this problem. Hope you got the idea and approach. Again, I giving the high level. I have to create the build tree for recursive call I used, and in the recursive call what I did, I have a two input pre-order in order. In the pre-order what the root value we are getting the first position. This root value then again we are getting in the second position in the in order, because you know in the pre-order we have a root left right, in the in order we have a left root right. So basis on that we are checking and create the node for this, and again after that we have to get the position from which to which, start to end, and that's why I keeping the here pointer. And for the recursive call I have to the base condition, so I base condition is like start is greater than end, then we have to return the null, otherwise I have to create the root. For the root value I have the taken the value from this pre-order. I create the index for taking each position or each value I can say. So that's why I taken this value or index variable, and find the index root left root right similarly for this recursive call, and I finally got the root left and right. Basis on this we have to return the root, so I returning the root here. So you can see our code is ready and paste is also passed, paste is also accepted. Yeah, and for this need to be know about the time complexity and space complexity. Please comment it down for this problem what is the space and time complexity. Thank you.